Now we're going to talk about inequalities and graphs. When you're working an inequality type of problem, you're going to encounter one of these four symbols. You'll either see less than, notice the smaller point of the symbol is to the left, and the open part, many people envision that as like an open mouth, excuse me, is to the right. The proper use of a less than would be something like 5 is less than 12, which is true. Next, you would encounter less than or equal to. The equal to part is that line underneath the less than symbol. Properly used, you could compare numbers that are less than each other, such as 5 less than equal to 12, or numbers that are equal to each other. 12 is less than equal to 12 because of the equality. Greater than is that same symbol flipped around, so the larger number would come first when properly used. And greater than equal to has a similar point to less than equal to. You can use that with numbers that are greater than each other or numbers that are equal to because of that line underneath. Now, when you're graphing on the number line in inequality, you will notice that either the graph will be shaded to the left. It will always be shaded left when it has anything to do with less than. Then it will be shaded to the right if the original problem has anything to do with the greater than symbol. You will also use a closed circle if the less than or equal to has the equal sign underneath it, and there will be an open circle if your less than or greater than sign does not have the equal to. Now let's try this. On this first example, it's written in set builder notation. So just disregard the first x and you will graph x is greater than -1. If it's greater than -1, it will be shaded to the right and it has no equal to sign underneath it. So I have an open circle on the -1 and I will shade that to the right. On this second example, again, disregard that first x, that's part of the set builder notation. Your job is to graph x less than equal to 6. Well, I go to +6 and it's less than that, so it will be smaller, it'll go left, and it has the equal to sign with it, so I have to put a closed circle on the 6, and then I would shade to the left. Now, a double inequality is when you have double symbols. You will have two of the less thans or greater thans. Here, I notice I have no equality beside that -3 in x, so that would be an open circle. I do have the equal sign underneath between the 1 and the x, so that's what we call the closed circle. So I have an open circle on the -3 and a closed circle on that 1. Since x is in between those two numbers, you shade in between these 2 points. Now, here are some problems in which you first must solve for x before you graph. When you solve inequalities, you use the same strategy as with an equation, except for you have to remember to reverse or flip the direction of the inequality if you ever divide by a negative number. For instance, here, I see I have to solve this inequality, so I move over the 2. It's a subtracted 2. Now that is subtraction, not dividing, so I don't flip the symbol, and I end up with x less than equal to 5. So I'll have a closed end point on the 5, and it will be shaded to the left. On this second example, however, the -7 is a coefficient. The only way to properly solve that is to divide both sides by -7. That would leave x and -3, but since I divided by a negative, it now becomes greater than. You will flip or reverse the direction of that inequality. Then I know I have to have an open circle on the -3 because there was no equal to underneath that symbol, and it will be shaded to the right. Now here's another example. we need to solve for x. I can move this 2 over, making it a subtracted 2. So 6x less than equal to 5x plus 2. Then I will in turn subtract the 5x. So I have x less than equal to 2. And I would graph that as the 2 with a closed circle, and it would be shaded left. Now, application problems can be used with inequalities as well. Here we have a car that can be rented for $55 per week plus 30 cents per mile. Algebraically speaking, that would be $55 plus the 30 cents per mile, because we don't know how many miles we have gone. The next question asks, how many miles? So that would be our unknown x. But that question says, how many miles can be driven if you have at most $340 to spend? We do not want to spend over $340. So $340 is the max we would ever spend. So I can say that this charge for the car has to be less than, or it could be equal to, because I do have $340, but it cannot go over that. Now, let's solve this. If I subtract the $55, then I have 0.30x less than equal to, and just go ahead and do that subtraction, it's 285. And then I would divide by the coefficient 0.30. And that would be 9,500 miles. That can be driven with my $340. Now here is another example of using less than, greater than, comparing things, seeing how much of something you can do. I have this elevator at a construction site that has a maximum capacity of 1,825 pounds. Now you have an operator that's going to hop up on this portable elevator who weighs 275 pounds. So if the maximum weight that this portable elevator, or lift it is sometimes called, if that maximum weight is 1,825 pounds, and I have a person on that machine operating it who weighs 275 pounds, then I cannot carry but a certain amount of materials, because you have to calculate in the weight of the individual. So I can actually carry 1,550 pounds of weight in construction supplies. We are told that each cement bag, that must be the reason for the lift, is to haul up some cement bags, but each cement bag weighs 50 pounds. So how many bags of cement can be safely lifted? Well, using this line of thought, you would not necessarily have to set up a formal inequality or equation. You could simply divide now by 50, because that's how many pounds you have per bag of cement. And if I divide the weight that I possibly can use, disregarding the weight that I've already subtracted for that operator, I'm going to divide all that by the 50-pound bags, you can at most carry 31 bags. You would not want to carry 32. Now here is an example of a cell phone plan, and we have it described that it's $10 a month. Then you get 60 calling minutes for that, but any additional time is 50 cents per minute. Well, the formula is given to us that calculates all of that. So I have the cost is 10 plus 0.50 times x minus 60. Now it says how many calling minutes are possible for a cost of at least 25 and at most 40. So the cost has to be between $25 and $40. In a question like this, you would set up what we have seen and what we called a double inequality. Remember, the double inequality has a double symbol, so I would put $25 for the low end and then that's going to be my cost. The maximum end would be $40. So it has to be at least $25, but then it will be at most $40. Now the cost is calculated by the equation, the formula that was given. So I replace that with 10 plus 0.50 x minus 60. Now I must solve for x. I would start off by using the distributive property in the center. So I have 10 plus 0.50x, and then I multiply that 60, and that's going to be a negative 30. If you notice, the 10 minus 30 would be negative 20. That would make it a little easier to solve. Then I will add the 20 to all three parts of this problem, leaving 0.50 in the middle. So I now have 45 on the low end and 60 on the high end. And last, I divide by the coefficient on all parts. So x, the number of minutes, would be, let me see, 45 divided by 0.50 would be 90 minutes on the low end, and 60 divided by 0.50 is 120 minutes. So that would be the number of minutes needed on this problem.